In this video, I'll be working through the question you can see on the screen here from the summer 2025 Cambridge A-Level Maths paper 3-2. I'm going to try and show you how to do this question and not just the solution. So you may need to pause and rewatch certain parts of the video. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 7, we're given this trigonometric expression and we're asked to put it in this form. This is quite a common question. In fact, they might go so far to just give you this and ask you to try and solve it. They want you to know to use this, and what we do is we put them equal to each other. This is a common way to basically, if you ever have cosine and a sine and you want to add them together, there's a method we can do this by turning them into cosine. So hopefully you've seen this before. How do we do it? This is cosine of an angle minus another angle. We can expand that out. It's in our formula tables. This side here is the same as or multiplied by, well, let me just check my notes. Yeah, here we go. Cosine the first angle, sine, oh sorry, it's both cosine on this one. Cosine the second angle, minus, no, plus, or multiplied in would be or sine the first angle, sine the second angle. Now that might not look special, but what we've done here is we have a cosine theta on the right and a cosine theta on the left. We have a sine theta on the right and a sine theta on the left. What we can do at this point is have like terms equal, just like we did in a previous, I think the last question in fact. We can say all the numbers in front of sine. That's yeah, let's put it up here. That's 7 on the left, and all the numbers with sine theta on this side is or sine alpha. Similarly with cosine, it's 24 is on the left, and with cosine here we have or cosine alpha. Again, if you've done this question, practiced this question a few times, you should be getting to this point. We do the same thing next. We have two equations, two unknowns, so there is ways to solve this, and there's two different ways to solve this. But if you don't remember what you've studied, you might get a bit stuck here. So what do we do next? I want you to think of ways to destroy things here. And when it comes to sine and alpha, there's two things that come to mind, and that's the two different ways we're going to do it. Sine divided by cosine gets rid of them, it turns them into tan. And another way is cosine squared plus sine squared. That gets rid of them, turns them into just 1. So that's two different ways. Let's do the divide first. Let's divide sine alpha by cosine alpha. Or let's divide the whole right side here by this whole right side. If we're doing that on the right, we better do it on the left. So that's 7 divided by 24. This one divided by this one. So divide the lefts, let's divide the right. Or divided by or, that's 1. That's fine, that's gone. Sine alpha divided by cosine alpha gets tan alpha. And what I've done there is actually, not so much the alphas, I suppose, I destroyed the ors. So we're just left with an alpha. This is an equation with one unknown. We can just solve that. Alpha is equal the inverse tan of 7 over 24, and that comes out as 0.2838. And actually I think that's the question. That's part A. They didn't actually ask us to find or, which is a bit strange because we're going to need or for the next part. And 9 times out of 10 when they ask a question like this, they ask for or and alpha. So unless I'm misreading it, they didn't ask for or, you're finished. But let's just find or anyway, because like I said, we do need it for the previous part. How you can find or, there's two ways at this point. You could just take this number and put it back in here, and it will, the 24 divided by cosine of this, if you've used the perfect number in your calculator at least, will give you or. If you haven't, it'll give you something very close to or. But let me show you the main way. If instead of these two equations, if I square both of these, so I get 49 is equal or squared sine squared alpha. Haven't changed anything. Square both of these, I get, I don't know what 24 squared is, I'll just leave it as 24 squared. Or squared cosine squared alpha. What I can do now is add both these together. Add the lefts, add the rights. I get 49 plus 24 squared on the left, and on the right I'll get r squared plus r squared times sine squared plus r squared times cosine squared. Take the r squared out of both of them. I'm left with sine squared plus cosine squared, and like I said a few moments ago, that's 1. This all equals 1. So we're just left with r squared is equal, I'll just leave it as this because I don't think I wrote down the numbers in my calculator. That means r is equal square root of this. And if you put that into your calculator, you'll just get 25. So the problem with doing this way, your calculator might have told you the answer was, I don't know, 24.98 or something like that. And the examiner would take a mark away, but they wouldn't. The rest of the question, they wouldn't penalise you more. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, in part B, they ask us to solve this equation. They say hence solve this equation. Hopefully, I'm really hoping you all notice that this looks very similar to up here. It's identical if you just replace theta with x over 3. That means this side, which we now know is 25, cosine theta, replace theta with x over 3 minus, and what was the number we had there? 0.2838. I hate using this rounded off number. I like keeping the perfect number in my calculator, but we're going to use this so much that it certainly wasn't worth it. An extra note on how we got 25. I do think the exam messed up by not asking you to get 25, but I would point out it's very common to get, and if you just square, it could be got just by 7 squared plus 24 squared, the square root of it. That's where this comes from. So I think maybe the examiner just expected you to know that, to be able to jump straight to that. I don't like it. I don't like what they've done there. But anyway, so instead of solving this horrible equation, we now solve this one here. Let's put a block around it. This times that. It has one unknown. It has x. It's nothing too complicated, in fact. They ask us to give the answers, all the answers between 0 and pi. They don't say it like that. They don't say between 0, all the answers between 0 and pi, because that'd be giving you too much of a clue. But this question comes up all the time. Let me skip ahead even. I usually say this at the end. We're going to end up solving a cosine here. So cosine looks something like this. Cosine has millions of answers. Like, let's say when cosine equals, I know the answers are positive up here, but I'll just pick negative. Minus a half. Minus a half. There's an answer, there's an answer, there's one, there's one, there's one. There's millions of these answers. And what we often get in these questions is we want lots of them. In fact, sometimes we want weird ones. Calculator would just give me this one here. But sometimes maybe we want this one and this one. Or maybe we want the 2 minus ones. So we have to be really careful, especially when lots of work is going on inside the cosine. Like the answer is going to get multiplied by 3 and we're going to have to add this to it. So it's going to mess it up. What you can do is try and draw this now. And that's not as bad as it sounds. We're going to end up multiplying everything by 3. So, well, let me just sketch it out. It's not necessarily how I do it. But instead of cosine like this, going up to, sorry, there's 2 pi here. This is a cosine x. Cosine of x over 3 would just look like, so if you put in pi here, we would actually get pi over 3, which is this one. So here's pi. If I put pi and 2 pi down here, if if I put 2 pi in, I actually just get 2 pi divided by 3, which is somewhere like around here. It's not till 6 pi that I would get 2 pi. So I'd have to continue this on, put in 3, actually I need this much longer. I'll rub this back out in a minute. 4 here, 5, and then 6 here. This would actually look like something like, this should be the very bottom here at 3 pi. And where does it come up? Sorry, no, it doesn't go up through there. Sorry, no, it goes down through there, okay, and up through here. Something like that, really elongated this becomes. And then taking this away from it is like adding, it's like moving everything over here to the right. So let me just do this on one picture. I'll move that over there. And we'll be down there. Multiplying by 25 just gets a 25 up here. So when is this equal to 24.5? Well, that'd be here. There's one answer, there's another answer, and the only answers we want is between 0 and pi. There's pi, so this will be the only 2 answers, this one and this one. Or maybe this one isn't even in it. I'd have to draw it better. So you could do this at the very start to help you out. So really, the one answer I'm definitely looking for is actually this one here, the minus answer from the original cosine. And maybe the second one, because I moved everything to the right. Okay, I'm sorry, that was a bit of an aside, because you don't have to do this. You don't have to think of it this way at the start. I'm going to go through the question from here and show you more of a simple way you can do it. I'm going to show you just to get like 6 different answers. And stay going through the question, and then you'll see which are right, which are between 0 and 3.14, which is pi. So let me rub this off, but this is another way to do it. We can, when we get the answer for cosine, we know the answer we're looking for is the one the calculator gives us and minus the one the calculator gives us. But I'll forget we know that as we go through the question and see how it comes out. Okay, I apologise if I lost anyone with that waffle. Let me start over a little bit. We're just going to solve this equation. Let's rearrange some things. We'd get 24.5 divided by 25 is equal to cosine x over 3 minus 0.2838. Take the inverse cosine of both sides. We get the inverse cosine of 24.5 over 25 is equal x over 3 minus 0.2838. We can stay solving this. I've made just a little mistake at this point. If I continue here, I've made a mistake, so I won't. But you could continue solving. You add this to both sides. This will give you, your calculator will give you an answer here. Add this to both sides, multiply by 3. Some students think they're finished. And you'd actually get one of the right answers here. But we're looking for 2 answers. What I want you to remember in questions like this is, when you get your calculator to do this work, your calculator is stupid. Your calculator will only give you one answer when there's actually millions. So what you've asked your calculator to do, I'll draw one last picture, I promise. What you've asked your calculator to do here is to, this number, 24.5 divided by 25 is about like 0.9 something. It's all the way up here. You've asked your calculator to find this point here, and it will answer. It will give you out this answer. Yeah, so this here will give you, let me write them all down here. It'll give you 0.2. I think it's 0.2000 something. Definitely rounds off to 0.2. That's this. That's 0.2 in radians. But I want you to remember, your calculator is stupid. There's actually more answers. There's lots more. There's, for example, 0.2 is an answer, sure, but so is minus 0.2. Just as good an answer. It's just as possible of an answer. This here is 2 pi, or like 6.48 or something like that. So if this is 0.2, what's 0.2 away from there? I've jotted some of these down. They might not be perfect, the numbers. I was just going rough numbers for the moment. This number here will be about 6.28 minus 0.2. So, oh, that is what I have, 6.08, something like that. And there'll also be a minus. 6.08. There's infinite ones. I'll just do one more. Yeah, I'll do 6.48. That would be this one here. 0.2 after 2 pi. There's all these answers and more is the answer to this part. So whenever you get the inverse cosine or the inverse sine, I want you to maybe write them all down or at least think about it, okay? So we're going to think about it at this point. So we are then going to add this to this side, 0.838 to this side, which means we're going to add it to all of these. And all of these will equal, have I done that? Yeah, I think I've done that somewhere. Yeah, I think I've just done it roughly. Adding this number to all of these, we get, I guess I can do this in my head, 0.08, again, just roughly, 0.48, 6.36, 6.4, 6.6, 6.7, 6, I guess, minus a 5. No, I'm still not seeing where. I definitely wrote this somewhere. Minus 5.8, I guess. Roughly, this would be the answer if I add this to both sides. Next, I need to multiply them all by 3, and that would give me the final answer. X is equal to all of these multiplied by 3. So roughly, not the exact answer yet, sorry, minus 15 plus 2.8 minus 17.4. This is one of the answers. We'll have to do this one again a bit neater. This would be about 0.24. That looks fine as an answer. This one multiplied by 3, about 1.32. This one multiplied by 3, that's way outside the range. 18, about 19. This one times 3 is about 20, something like that. The only answers I'm interested are between 0 and pi. 0 and 3.14. This one's out. This one's out. This one's out. These are the only two answers. I knew that from my drawing earlier. You'll lose marks for this because I wasn't too neat. Go back here and let's add these properly. We will get this plus this number. That's sorry. This plus this multiplied by 3. And I think I've wrote down the actual good answers here. Ah, here they are. So it's not 2.4, it's actually 0.251. 3 decimal places, three significant figures they always want. And this, oh wow, that was miles off. This is actually 1.45. So that is 0.2 plus 0.2838, then multiplied by 3 gets 1.45. Again, that's 3 significant figures. That's why this is 2 decimal places and this is 3 decimal places. I think they will take a mark away if you only put 2 decimal places here. If you put 3 here, you're fine. I'm tempted to tell students just always put 7 decimal places because they don't take marks away for being extra right, but they do take marks away for not putting enough down. Anyway, that I believe is the correct answer here. I hope you followed what I was doing there. I just don't really have room to do this question out 6 times and then throw some of the answers away. You do have to think a bit logically at this point that, oh, I'm going to add this number to it and I'm going to multiply by 3. So any minus that's more than this away is gone. So I can discount all of them. This minus though, that's snuck in. A lot of students are going to miss this one. Can't throw that away yet because we're going to add this number onto it. So it's no longer a minus. It's a small number multiplied by 3, which will get us right in the range we want. This guy's small enough as well. After we multiply by 3, or add this and multiply by 3, it's still okay. This is way too big. I could throw this away already. So when I did this, I could probably already have gone, these are the only 2 possible answers. And it did work out that they were the 2 answers. Okay, I hope I explained that somewhat okay. I'm not happy with that question, but I don't have time to redo it, so I'm not going to redo it. I'm going to let you guys ask me questions in the comments. Do you want me to explain something better? Did I make any mistakes? Things like that. Let me know in the comments. Okay, thank you for watching and have a great day.